All right, so we had a due date this past weekend for chapter 9/8. So that should have been done yesterday. And then today we're going into the last chapter of pre-cal. Yay. And I actually like to end, I find that this chapter is one of the easiest, in my opinion. So I like to end on a good note. So usually things go a little bit smoother on this chapter. And then that'll be it. All right. So let's see. Okay. So chapter 11 is conics. Okay. Don't make me draw. Hold on. Let me share my screen. If you look at the top of page 119, you have two cones, right, that are on top of each other, with their kind of vertices touching, right? And then when you, like, let's say that you took a piece of paper and you were to slice through this conic, you can make different conic sections. One's a circle, one's an ellipse, one's a parabola, and then you can cut it to have an hyperbola. Okay, so those are those cross sections that you see when you cut through a conic with a piece of paper, like a plane, a rectangular plane. So we're going to actually go through each different conic section, type of conic. And yeah, I mean, you've worked with them before, but we're really just going to get to what makes a parabola, okay? So section 11.1, we're just going to take a deeper dive and we're going to take a look at parabolas. Now, how parabolas are made? A parabola is a set of all points in the plane that are equidistant from a fixed point called the focus. Okay, so the fixed point is called the focus, and a fixed line called the directrix. Okay, so the fixed point is called the focus. And so let's say that you had a point, and I'm going to call this the focus. And then I have this line, and I'm going to call this the directrix. Okay. This point right here is equidistant. This distance is equal to this distance. And if I keep drawing, here's another point. This distance is equal to this distance. Here's another point. This distance is equal to this distance. And they'll just keep being equal. They have to be equidistant from the focus and the directrix. You would come up with a picture that looks like this, which would be the parabola. Okay, so that's what a parabola is. So if you look at the bottom of page 119, I give you this picture and label everything. Okay, so I want you to go to the page 120 because we're going to look at the formula for parabolas. I'm going to write a lot of notes in the top of page 120. I think it's really important, and I don't think there's enough notes here. So I'm going to fill it in. Okay, so if you have, let me just make sure. Yeah, okay. X squared equals 4py. Does everybody see that? 4py. This right here is a parabola, and it's going to, and this is the note I want you to add, it's either going to open up or open down. Oh, that's supposed to be a D. That's supposed to be a D. It's going to open up or open down. How you know that is because x is squared. If x is squared, it's going to open up or open down. Okay? Something else I want you to write here is that you always open toward the focus. Okay? You're always going to open toward the focus. Okay? P is the distance from your vertex to the focus. P is the distance from the vertex to the focus. And then remember, you are equidistant from the vertex to the directrix. Okay, that's another note I want you to add. There's one more note, and then we can look at some problems. I'm just going to scroll up just a tad. There's something called a focal diameter. Okay, a focal diameter. And that is a line segment Okay, I'm stopping. So here's just a couple of notes I want you to know. So just to recap while you're writing, if your x is squared, if you see that x is squared and your y is not, that means the parabola is going to either open up or open down. This right here is the formula. Okay, and literally this is the formula only if you're centered at the origin, which we're going to be centered at the origin in this section. Okay, we'll elevate later on. P is the distance from the vertex to the focus. And of course, it's the same distance between the vertex and the directrix. You always open towards the focus. Your focal diameter, if you want to see what is that like visually? If you look at the parabola, if you want to draw yours in, I'm just going to grab a different color. It's the focus, and you're going to go straight out and touch your parabola. So straight across to touch your parabola, this right here is the focal diameter. Okay. The length of your focal diameter is 4 times p. So you actually see it in the problem. 4 times p is the length of your focal diameter. I have some questions. Yes, Melissa? That's what I just drew when I said for you to draw. No. Right. That's why I wanted you to draw it. Anybody else have any questions before we move on? Do we have this written down? Okay, so let's try a problem. Okay, the first example is x squared plus 12y equals 0. Okay, so the first thing that I would do is I would get this into standard form. So which means whatever squared needs to be by itself. Okay, so if I do that, you would have x squared equals negative 12y. All I did was move the 12y over. And it's because when you're dealing with parabolas, it's best to get whatever squared by itself. Okay. Then I'm going to take it a step further, and I want it to look just like, I'm going to write it up here, x squared equals 4py. That's standard form. Okay, so if I try to get that to look like that, wouldn't this become x squared equals 4 times negative 3y? We okay with that? So you can see that p is negative 3. Okay. So now I'm going to come over here, and you should have a coordinate plane. Now, if you look at the instructions and you look at what the note at the top of page 120, it says that if you have this right here as your standard form, your vertex is at 0, 0. And that's what I was saying before, that our vertex is going to be the origin, 0, 0. Is that okay? So your vertex starts here for your parabola. Now, P is negative 3. So if P is negative 3, and remember, P is the distance from your vertex, right, to your focus. So I'm going to go 3 units down. 1, 2, 3. 3 units down. This is my focus. So your focus is at 0, negative 3. Is everybody okay with that? Any questions? Okay, your directrix is the same distance, but the opposite direction. So your directrix would be 3 units up. 1, 2, 3. This line is your directrix. Okay, this is the line y equals 3. Yeah, yes. You're putting the actual point. Well, I don't know. I didn't do your homework, but I would think so. Yeah, if it's asking you where your focus is, it's asking like where it is on the graph. If it asks for P, then you would put negative 3 in. Just negative 3, because that's P. Mm-hmm. Okay, so then the problem is I don't know how far out I go. Don't draw this. Don't draw this. Do I come over here and make it super skinny like this? Or do I make it kind of fat, like wide? Like, how do I know how I'm supposed to draw this? Does it make sense? And so what you can do is you can find your focal diameter, okay? You can find your focal diameter. And my focal diameter, I'll come over here. Remember, the length of it is 4p. So the length of it would be 4 times 3, which is 12. Is that okay? So you have 12 as your length. Length. Before you ask, length. It's not negative because we're talking about a length. Do we agree? So that means 12 is how long the diameter is, and you're going to go 6 in each direction. So if I come over here, you're at 0, negative 3. If you go 1, 2, 3, 4, 5, 6 out, you would have 6, negative 3. And then if you go 1, 2, 3, 4, 5, 6 out, this would be negative 6, negative 3. And there are 2 more points on your parabola. Getting a different color. This right here is your focal diameter. It is 12 units long. 12 units long. So it's just telling you how long that's supposed to be. And then it gives you 2 more points on the problem. Okay, now I'm ready. Any questions? Honestly, I don't know. I should have tried looked at your homework. I don't know. I don't know if it asks you for the length of it, so then you just say 12, or if it asks you for the points on the focal diameter, because then you would put -6, -3, and then 6, -3. You know what I mean? Like, I don't know. I don't know how they ask it. So just answer the question that's being asked. If it asks you how long it is, 12. If it asks you for the points, then you put the points. Is everybody okay with how we came up with this parabola?
Yeah, I think so.
Okay, next page. Okay. So on the next page, we're going to do this one together. First, let's start with notes. At the very top of the page, you should see that you have y squared equals 4px. So notice how the y is being squared. So this does not open up or down. This opens right. Oh, erase. It opens right. Of course, if your p is positive. It opens left. Of course, if your p is negative. Is there anything else I wanted to talk about here? Nope, that's pretty much it. Everything else is pretty much the same. I don't know if this helps, but your directrix, maybe I didn't write this on the other one. Your directrix would be x equals a number, where up here, I didn't write it down, but your directrix, if this helps you, remember, is y equals a number. And the reason why, if you come over here and look at our directrix, we had y equals 3. Your directrix is a horizontal line. So a horizontal line is y equals a number. Over here, we're going to have a vertical line be your directrix. So it's going to be x equals a number. Is that okay? Does anybody need me to go anywhere? Ready to start? Oh, sure. Yes. Yes, I can. I'm sorry. I forgot to add it when I just did it. At the very beginning one, where x was being squared and it opened up or down, we talked about the focus, how p is the distance from the vertex to the focus. And we talked about that you're always open towards the focus and that you're equal distant from the vertex to directrix. But I didn't really talk about the equation of this line. Since this is a horizontal line, the equation for it will always be y equals a number, the equation of that line. And then for this one, since it's going to open left and right, that means your directrix is a vertical line, right? And so if it's a vertical line, it's going to be x equals a number. Okay? All right, so let's try a problem. We have x plus 1/5 y squared equals 0. Remember, what are you trying to get by itself? Here's the
squared.
Whatever squared, you're trying to get this by itself. Also remember, the vertex is at the origin. Thank you. Sorry. Okay, so your vertex is at the origin when it's set up this way. So if you were to get this squared, here's some algebra. I'm going to have 1/5. So I would have this if I already get y squared by itself. Is everybody okay with that? And then I want it to look like this. This is my standard form. So I'm going to come over here and I'm going to have y squared equals 4 times p times x. So what is p? 4 times what gives you -5? What's p? Yes, and thank you, Alec. But it would be -5/4, but yes. So -5/4. So this and this are exactly the same thing. They're the same, except that I made it look to be standard form. 4 times -5/4 is -5. It's the same thing. But here you're able to see what your P is. Okay? All right, so now I'm going to come over here and sketch a picture. My vertex is at 0, 0. Your P is -5/4. So -5/4 would be over here. -5/4. Here's my focus. Not always, just right now. Right now with this form. That's why I'm pointing at that form very specifically. It's not always going to be. When we get to section 11.4, our vertex is going to be everywhere. So right now we're just learning the basics. We okay so far? So your focus is at -5/4, 0, right? -5/4, 0. So then where is your directrix?
+5/4,
Well, I agree that it's +5/4, but remember, your directrix is not a point, it's a line. So here's your directrix. So your directrix would be x equals 5/4. Is that okay? And then which way does the parabola open up?
to the left.
It would open up to the left. Good job. But then I don't know how to make it. I don't know to make it skinny or to make it fat, to make it wide. I don't know. So I'm going to find my focal diameter. Now remember, the length of your focal diameter is 4 times p. So it would be 4 times the 5/4. You could say -5/4. Remember, we're just talking about distance, though. We're talking about length. So the length of your focal diameter is 5. Is that cool? The length of your focal diameter is 5. The negative doesn't do anything except tell you how it opens. Does it open up? Does it open down? Does it open left? Does it open right? So we know this is going to open left because it's negative, but the length of your focal diameter is 5, which means you're going to go 2.5 in each direction. So this is up 2.5, and this is down 2.5. So I'm going to go across to 2.5, 2.5, and here is my picture. So the points on our focal diameter are going to be, what is that? -5/4, comma 2.5 and -5/4, comma -2.5. Okay. Isn't our focal diameter just when what's in front of the x before? Yes, it is, Jude. Yes, it is. Jude's asking, hey, did I really have to do this part? I mean, I could have just looked at this and saw that it's 5. And that's true because whatever's in front of the x is your 4p. I'm just highlighting that again. So yeah, you could just look at it and see that it's 5. And then you have to split it in half because you have to go in both directions so that you have a full length of 5 going from point to point. How are we feeling? Any questions on this one? Okay, great. Okay, so example 3, I have 4 problems for you. And in these 4 problems, I tell you different things, okay? And so I want you to look at those 4 problems. I'm going to give you a couple of minutes. Y'all can talk to each other. You just can't talk to me. And what I want you to do is I want you to come up with the equation in standard form for every parabola. The equation in standard form for every parabola that I'm talking about. So I'm going to mute myself, give you a couple minutes, and you try. All right. You should have a head start, right? For me, I haven't even done any of these. So these will be a surprise. I can't even find my pen. Oh no, I don't know where my pen is. There it is. Okay. All right, let's go through these. I said I haven't done them, so I don't know what the answers are. Okay, can y'all hear me okay now? Yes, no, maybe?
Yes, ma'am.
Okay, so A says, remember, these are all going to be centered at the origin. Because it said in the problem that its vertex is at the origin. So then you know that your focus, 1, 2, 3, 4, 5, is at 5, 0, which means it's going to open this way. We agree with that? So then you know that your P is 5. So then, since it's opening left or right, you're starting with y squared equals 4 times P times X. So you should have gotten y squared equals 20x, and that's the problem. Now, of course, I can ask you other stuff. Like I can ask you, where's your directrix? 1, 2, 3, 4, 5 this way. Here's your directrix, which is x equals -5. So I don't want you to get hung up on just like, oh, that's all. Like you should be able to label everything based on just the one little piece of information I give you. Does that make sense? You should be able to find these points on the focal diameter if I asked you to. We okay? Is there any questions on A? (20x minus 0). I'm sorry. Oh no. So no. I see what you're saying. No. It's just the one that we were boxing before. This is standard for x squared, and the ones I have boxed. So that's why when we had this, notice how I got it into this form first. Does that make sense? Okay. All right. So part B. What does B say? B says that the focus is at 0, -1/4. Okay. So again, we're centered at the origin. If your focus is at 0, -1/4, that's here, right? 0, -1/4, which means you're opening this way. You open down. So that means x squared equals 4. And then your p value is the distance. So your p value is the -1/4. Y. So you get x squared equals -y as the equation. We okay? Yes, no, maybe? Okay. Part C saying your directrix is at x equals -1/8. So if you draw a picture, x equals -1/8 is a vertical line. So here's -1/8. You have this vertical line here. If your vertex is at the origin, that means that at +1/8, you have your focus. And you're opening this way. So then I have y² equals 4. We open to the right, so I know that this is a +1/8 x. Do we agree with that? All right. And then D opens downward with a focus 6 units away from the vertex. So here's your vertex at 0, 0. Opens downward. So here's your focus. So you should have x² equals 4, -6y. Any questions? Because it opened down? Right. X² opens up and down, y² opens left and right. Uh-huh. Yeah. We okay? Any questions? All right. Let's try 2 more. So in example 4, I gave you 2 pictures. In example 4, I give you 2 pictures. I don't really give you anything else. You have to look at the pictures and see what I'm trying to tell you. So I want you to find the equations of those parabolas. I'm going to give you a couple minutes and then we'll talk. Y'all are super quiet. Is everything okay? All right. We're on example 4. If you look at part A, Didn't it tell you that the focus was at -3? Do y'all see that? And it's opening downward. So you should have x squared equals 4 times -3y, which is x squared equals -12y. Is everybody okay on A? Yes, no, maybe?
Yes, ma'am.
Okay. All right, sounds good. Okay, what about B? Did anybody get in a formula for B?
Y squared equals next. Ooh.
I didn't hear either of y'all because y'all were talking at the same time. Sorry.
I got what Garrett got. Y squared equals 16x.
Hmm. I didn't get that. I could be wrong though. Anybody get anything else?
Alex said he got 1/4 x.
I think you forgot to do something, Alec, but I'm liking where you're headed. Anybody else? How'd you do this? Anybody?
Well, for me, I just went, he gave us the points x and y, and I just saw x is 4, so I just plugged it in because it's in the middle. I don't know. Yeah.
So do you agree that the formula is going to be y squared equals 4px? It's y squared because it's opening to the right. Do we agree with that?
Yes, ma'am.
So if this is an x value and this is a y value, you would have -2 squared equals 4. We don't know what p is, but we do know that x is 4. So that would give you 4 equals 16 p, and therefore p is equal to 4 over 16, which is equal to 1/4. What? I don't know what the focus is. Do you know where the focus is? It doesn't show the focus in the picture. Okay, you tell me what you started with. Okay, hold on. Do we agree it's opening to the right? Okay, so then do you agree that we're going to start with y squared equals 4px? Okay, so then do you agree they gave us a point that's on the parabola? Yeah? I didn't hear a yes. Are we okay? Melissa, did I lose you? Okay, so there's a point that's on the parabola, 4 comma -2. 4 is an x value, -2 is a y value. So I substituted those values into the formula for y and x to solve for p, because I don't know where the focus is. So you have no idea what the p is. So then I did algebra and I solved for p. So p is 1/4. And this is what I was talking about with Alec. I think Alec got 1/4 for p, but then you have to plug the 1/4 back in. And so then you plug the p back in for p, and you simplify it, and you get y squared equals x. So y squared equals x is a parabola that opens to the right and contains that point. Okay? Any questions? Okay, next page. So the next page is we have this lamp, okay? Has anybody ever looked into a flashlight? If you looked into a flashlight, you see how the bulb kind of protrudes a little bit. The bulb is not necessarily sitting on the very back of the flashlight. It's like actually up a little bit. So if you read through this, it says a lamp with a parabolic reflector shown in the figure. The bulb is placed at the focus. So they're telling you that the bulb is placed at the focus. And I'm also telling you that you have a focal diameter at 12 centimeters. The first thing I want you to do is I want you to find the equation of this parabola. And then I want you to find the diameter of the opening of the flashlight. So, oh my gosh, you're going to make me draw. All right. Okay, let's pretend I'm going to draw a coordinate plane. I would always put your vertex, if you have a choice, I would put your vertex at 0, 0. So I'm putting the O there. If you look at your picture, there's the O. Then you have this lovely parabola that's opening this way, right? But this is not a parabola, it's actually a flashlight. So this is the opening of the flashlight right here. This is C, this is D, okay? And then they told you that they put the bulb at the focus. And then they even told you that the diameter, the focal diameter, is 12. So it's going 6 in each direction. I'm totally cool with all of that. So my question to you is, what is the equation of this parabola? What is the equation of this parabola? This is what I'm talking. I feel like we do notes in class and then you get home, or you're at home right now, and you do this, you get a problem like this, and you're like, she didn't do like one like this in class. How are we supposed to do this? I gave you all of the tools that you needed to figure it out. You just have to think. Can you find P? Y squared. Yes, it is. Good job. Okay. So how'd you get that? Explain. Cool. So 4P is the length of your focal diameter, and they told you that the length of your focal diameter is 12. So you can just replace that 4P with 12, and you get y squared equals 12x. But it is good to know that if that's 12, then your P is 3. So I know that I'm 3 centimeters from here to here. Is everybody okay with what she said? That was great. Everybody good? Okay. Moving right along. The next thing said, what does it say? Oh, find the diameter from C to D of the opening that's 20 centimeters away from the vertex. Okay. So they're telling you, I'm going to get a different color, that you are 20 centimeters away from the vertex. That's 20. I want to know, how big is this? How are you going to figure that out? I'm cool with you plugging in 20, but you wouldn't plug in 0. So you're right that x is 20, but remember, this right here is not a point on the parabola. That's just how far out you're going to go. These are your points on the parabola. So you're going to plug in 20, and so you get y squared equals 12 times 20, and this is going to give you y squared equals, what is that, 240? Take the square root. Does that simplify? Okay, so 4 to the square root of 15. So the distance from here to here is 4 to the square root of 15. That's from here to here is 4 to the square root of 15. So then what are you going to have to do to that? This is the length of the opening, whatever that is. Someone round it to the nearest centimeter. About 31 centimeters. So the flashlight, the edge of the flashlight is 31 centimeters long. You're to measure it. And there you go. How are we feeling about parabolas? Any questions? Okay. Let's start on ellipses. Just the notes part. We're not going to get into any examples, really. Just the notes part, so I don't have to do that tomorrow. Okay. In 11.2, we are going to start looking at, that's an E. That was my marker. We're going to start looking at ellipses. Okay. An ellipse is a set of all points in the plane, the sum of whose distances from two fixed points called foci. So foci, go in that first one, is constant. So let me explain what that means. Let's say that you took 2 points. We're going to call this foci 1 and foci 2. And you took a string, a piece of string, okay? It could be like a little bit loose. And you were to tape the edge of the string to here and one edge of the string to here. And then you were to pull it taut. So you can kind of see a really good example of that on the paper. So you were to pull it, here's the edge of the string. And you were to loop this bad boy around, keeping the string taped. You would get an ellipse. You would put your pencil and then trace it all the way around, keeping the string pretty taut. You get an ellipse. That's my ellipse. It looks like a potato. If you look at the middle of page 124, these are parts of an ellipse. We're going to, at first, just to learn about ellipses, we are going to center it at the origin, okay? So in this section, the center of your ellipse is going to be at the origin. And then I want you to take a look at how it's stretched. If it's stretched this way, then this here is called the major axis, and this would be the minor axis. So minor axis, major axis. But if it was stretched this way, then this would be the major axis, and that would be the minor. So it's pretty self-explanatory. The longer one is going to be the major, and the smaller one's going to be the minor. So at the very bottom of page 11.2 of page 124, A is the distance from the origin to a point on the major axis. Okay, A is always associated with the point on the major axis. The points on your major axis are your vertices. So that's vertice 1 and that's vertice 2. If we were doing it this way, that would be vertice 1, vertice 2. The length of your major axis is 2A. The length of the minor axis is 2B. C is the distance from the origin to a foci. Okay. Distance from the origin to the foci. Note, between A, B, and C, A represents the greatest distance. A should be the biggest number. Because remember, your foci are inside of the ellipse. So this is not bigger than A itself, which is all the way to the end. Is everybody okay with my notes? Any questions? It's not that bad. Okay, looking at the first example, just to explain the notes a little bit, I want you to look at the top of page 125. It says x squared over a squared, right? Plus y squared over b squared is equal to 1. This right here is the standard form of a parabola. Ellipse. This is the standard form of an ellipse. I can look at this. I don't even need to know anything else. I can look at this and know that it's going to be stretched out this way. Your major axis is horizontal because the A is under the X. So when the A is under the X, it's stretched out horizontally. Your major axis is horizontal. Is that okay? And then, of course, your minor axis would be the y-axis, would be the vertical one. So if you look at the first example, it says x squared over 25 plus y squared over 9 equals 1. So if the center is at 0, 0, do you agree that A is 5 and B is 3? Because this right here is the equation. This is A squared and B squared is under the denominators, right? So then A itself is just 5 and B itself is just 3. Is everybody okay with that? So if I were to sketch this, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. This would be my ellipse. Are there any questions on where I got anything? So far, so good? Because are you talking about like in general or just right now? I'm going to show you. It's kind of like the unit circle. How like no matter which points you pick, it's always equal distant around. Does it make sense? No matter which point you pick on the ellipse, you're going to get this value. You're going to get the 1. Okay, so the foci, just because we're running out of time, the foci, how you find that is you need C. Remember, foci, the letter is C that deals with foci. If you look at the top of page 125, it tells you a relationship. A squared is equal to B squared plus C squared. So we know A squared is 25 equals, we know B squared is 9, but we don't know C squared. So C squared is equal to 16, and therefore C is plus or minus 4. Nope. What are your vertices? Remember over here? Your vertices are only the points along the major axis. These pictures. So on your work, your vertices would just be negative 5, 0 and 5, 0. Those are your vertices. Your foci, I'm filling in the questions now. The foci would be negative 4, 0 and 4, 0. This is where your string was taped. So negative 4, 0, and 4, 0, that's where your string was taped. And then you pull it straight and then go all the way around and you would make this ellipse. What is the length of the major axis? Length of major axis is 10. Length of minor axis, oh, is 6. Oh, don't let me mess up. Thank you, sorry. Length of minor axis is 6. And that's it. Is major and minor just determined by which one is longer? Yes. Yes, Alec. And remember, which one is longer, it deals with A. A will always represent your major axis. So this right here was the bigger number, so that's how I knew that A was 5. And since the bigger number is located under the x squared, I knew it was stretched horizontally. I'm not going to do it today, but if you look at the next, right under this example, you'll see that you have your A squared under the y. And we'll open up with that tomorrow. Okay? So hopefully you have this one down, and then I'll show you the vertical stretch tomorrow, and then we'll talk about some problems with it. And that's it for today. Fun, huh? It's not that horrible. All right. I will see y'all mañana. Y'all did good today. Good. At least y'all were working some stuff out, not just sitting there.